Miss Sarah, Miss Lorena, right?
Yeah.
Okay, so we're given two strings. This is S, this is T. We want to find out if S is a subsequence of these, yeah? Of these.
It's true.
Yeah, this is true. What's subsequent? Yeah, we talk about this all the time.
Because
Yeah.
ERIC.
Yeah, we're done. Okay. So what's subsequence? Subsequence is that this is the string, and then if we remove none or more, we remove some numbers of characters, and then it will become this. That will be subsequent. Yeah, not continuous. But if it's continuous, we call it substring. Yeah. We talk about this. Yeah.
Subarray.
Substring, subarray. Yeah. Sublist. Substring. These are continuous. So we have. If we want to prove false, we can usually do it with on square, right? On square, because what we can do, first of all we can. So how do we get this on square? Do you still remember? On square. We can first of all, if a sublist substring is one character, if there are n characters in the original string, so let's picking one index out of n, right? Okay? And how about if there are more than one character? That would be what? Picking two numbers out of n. Okay, so Cn1 is n plus Cn2 is n times n minus 1 divided by 2, right? So this is in the scale of on squared, right? Okay? Okay. So substring. Yeah, we talk about these substrings. A long time ago, we can use the 2 pointer. Yeah, do you still remember? How do we check it? How do we check? Look, how do we check these? This is a subsequence of these. Look, we have 2 pointer. Yeah, look at me. 2 pointer, I and J. Okay. E is not equals to A, so we move here. Okay. E is equal to E, so we move both. Okay. I is not equal, right? So I move here. Move the T. Yeah, and then R is equal to R. I move both. So to put it simple, if two characters pointing to the same position, put the characters at both pointers, yeah, both the string are equal, then we move both pointers. Otherwise, we move the T. Yeah, got it? Yeah. Why this is working? Why? Look. And at the end, if this pointer position reaches the end, then we have a match. All right. So to sum up, we want to move when we have a match, like E. If E equals to E, okay. So here I'm here. Yeah. E is equals to E, then I move both. Right. I move both. Okay. But now I is not equal to I. So what do we do?
Skip.
Skip which one?
I,
yeah. Because I can't skip this one, yeah? Because I need to find a match, right? So if I find a match, if I don't find a match, I can't skip, right? That makes sense, yeah? Mm-hmm. But if I find a match, I can skip both. I can move both, right? So as long as this reaches the end, then that will be there. Yeah? That's what we have talked about. Let's quickly implement this, okay? So it should be quick. Define is subsequent as Q. Okay, so if the length of S is bigger than Q, then we return what? Come on, one question.
false.
False, obviously, yeah. Because if the original string S is longer, then you can't find a subsequent in another string, right? That's very obvious, yeah. If length S is bigger than length Q, actually it's P, we just return false, right? Okay, okay. Then what? I equals 0, J equals 0. Okay. And then Y, I is smaller than the length S, and J is smaller than length T, right? Look, if Si equal Tj, then what do we do? Look, right? This is I, this is J. So what do? If we have a match, we move both pointer, right? So I plus equals 1 and then J plus equals 1. Otherwise what? Otherwise which pointer we need to move? Otherwise which pointer we need to move? Come on. This is S, this is T. This is the ERIC, this is the something else. So if we don't have a match, which pointer we need to move?
Then we need J.
J plus equals 1. Okay, and then in what cases we need to return true? In what cases we need to return true after this?
If I
Is the n, yeah? If return I equals then s, yeah? Obviously, yeah. So the time complexity is O, the longer one, yeah? So which is what? The longer one, no, Ln. N plus n, right? N is the number of string in the S, a number of characters in the S. M is the number of string in the T. But we know what? S is smaller than T, right? So we can obviously say it's On, right? Ryan? Yeah? The time complexity will be On, okay? Is it? No. Is it On? No. The time complexity will be the shorter one, which is On. N is the number of string in the S. Because look, there's no. Is it no more? Okay, so let's. So what's the time complexity? What's the time complexity? Come on. In what cases? Look, in both cases, j will plus equals 1, right? In the worst case, in j will be plus 1. In both cases, so t is the number of string in the longer one, yes, the longer one, yeah. Because it could be the case is you can't find even a match, right? You'll be like A, and then this character, and then the t will be B, right? So what happened in this case? So you can't find a match, so you always move this, right? Yeah? Yeah? Make sense? Does it make sense? The time complexity. So the time complexity will be the time taken to iterate over all the characters in the T, right? So the time complexity is O(n), okay? Okay, so this is two-pointer thing. So how can we do this using this recursive? How do we look using this recursive? Right?
Yeah.
So it's quite similar idea. Look. So look, I have a string, yeah? I have a string. Look, which is E something, okay? And then I have another, this is S, yeah? T equals what? T equals what? E something. Okay? So look, is S a substring of E? If I have a two-pointer point here, right? Yeah? So is it the same as because the first character is the same, right? So this question is the same as if S1 to the n is the subsequence of the T to the n, 1 to the n, right? Right? Makes sense? Look, the first character is the same, both is the same, so it's a match, right? Yeah, it's a match, so I just move it, right? How about if it's not the same? If S is like E something, and then T equals F something. So what's this going to be? So look, let's consider the first character. It could be only two cases, if it's equal or if it's not equal, right? If it's equal, then it'll be like that, right? So we just have to find out the smaller problem, which is from the first character, second character and onwards, right? Yeah. But this one, if it's not equal, then what happened? Right? Then what's the what does it equal? What does it equal? Yeah, skip. Well done. Skip which one?
T.
T. Yeah. So it'll be like S and then T, 1 to the n, right? Yeah. Alright. So that's two cases. Alright.
Yeah.
Two cases. Okay. So let's write. How we just write it? Yeah. That's two cases. Come on, Ryan. What did I just say?
It'll be in two cases.
What two cases?
That thingy.
What the thing? Come on, pay attention, okay? So let's say define is subsequent, okay? Subsequent as t, okay? But first of all, we need to define. We need to do what? If length s is bigger than length t, what should we return? If length s is bigger than length t, what should we return? Anybody?
Then false.
False, obviously. Yeah. Okay, now we define f function I and j, yeah? Where I is the s index, yeah? Tj is the t index, okay? Now look, if I goes to the n, what should we do? If I somehow goes to the n, what should we do? Return true or false? If I goes to the n.
True. False.
The I is the smaller one, like Eric, and then, yeah? True, yeah, obviously. If I goes here, then that will be true, obviously, yeah? Okay, then if j equals to the n, if j pointing to the n, return true or false? If we are running out of characters, if j,
False.
false, okay. Okay, now, two cases, do you still remember? If si equal tj, return what? Return what? If si equals tj, look, this is si equals tj, eric, and then it's e something something. If si is here, yeah? tj is here. So what does it equal? Come on, what does it equal?
It's equal.
F what?
F.
F what? Come on. This is the same as the remember, if both characters are equal, what do we do?
Skip both.
Skip both. So I plus 1 and j plus 1, yeah? Okay, and otherwise return what? Return what? F what? If it doesn't equal, which character we need to skip? F what? Come on, can you tell me?
T.
So look, come on. Alright, right?
Yeah.
I is the current position of S. J is the current position of T. If both characters are equal, we skip both, right? I plus 1, J plus 1. If the both characters not equal, like ERIC and then TT something, so these two is not equal. So which one I should move?
Skip T.
Skip T. T is J. Yeah, J plus 1. But how about the first one?
T. Yeah.
Okay, yes, skip. And J is the pointer, it's position for the T. Okay, so this is I, J plus 1. Okay, yeah.
Yeah.
Okay, so look, this is actually the same as 2 pointers in here, but written in the recursion. Yeah, recursion greeting. Why this is working? Come on. Why this is work? ERIC. Okay, come on here. Look, if I have something. Okay. Yeah, look.
Yeah.
So I have a match here. So I can just move, right? I don't have to wait for the second E to match, am I right? As long as I match first E, then I can skip, yeah? I don't have to match the second or third E, right? Does it make sense? That's greedy. Yeah. Do I have to wait for the next one? It doesn't matter really, right?
Yeah.
Does it make sense?
Yeah.
Because look, as long as I find a match, I can just skip to the next both, yeah? Advance the pointer to the next. Okay, this is from the left to the right. Can we do from the right to the left? Anybody?
Maybe.
The answer is yes. Look how? Look, this is ERIC, yeah? And how about let's say let's say AEIRAICI. Okay? Is this the match?
Yeah.
Yeah?
Yeah.
ERIC. Okay, so can we do from the right to the left? Not match. No, yeah? Match. So what do we do?
No, both. Skip both.
It's the same, yeah? Backwards, yeah? Is it the same?
Yeah. Yeah.
Oh, no. I is not the same as A. No, then what do we do?
Skip that A.
Yeah?
Same.
Same. Then what?
Skip both.
And? Not the same?
Skip the A.
Same.
Skip both. Skip I. Skip both.
Okay, and then we reach the beginning. Instead of checking the end, we do checking the beginning, right? Yeah, you got it. You know this algorithm, right? Yeah, it's the same, yeah? So what now? This is backward, yeah? So we can just do this, right? if I is smaller than what we do? I write it here. Okay, so okay, so look, return f. For this one, we just have to say return f. We start from the first one, f0 0. Okay, and then we can do another one. Okay, do another one. I'm going to write it here. If I is smaller than 0, it reaches the beginning, return true. It's the same, yeah? If j is smaller than 0, return false, obviously, yeah? If si equal sj, come on, anybody, what should we do? If si equal sj, return what? F what? Come on, this is I plus 1, j plus 1. How about this? If moving to the left.
J
Moving to the left.
minus
I minus 1, j minus 1. Eh? Otherwise, we return what? Come on. Here is fi j plus 1. So what happened here? If moving to the right is fi j plus 1, and moving to the left, f what?
I j minus 1.
Yeah, we're done. Okay, look, both way works, okay? And if we could call it, instead of 0, 0 from the beginning, we call it from the end. So return f length s minus 1 and length t minus 1, okay? Yeah? Start from the from the right. This is start from the left. Okay, so this is actually quite the same as the 2 pointer thing at the beginning, yeah? If we have a, so the core idea is that what? If we have a match, we move 2 pointers. Otherwise, we move the one which is longer, right? We move the pointer to the string which is longer, right? Because we can't skip the check of the we can't skip the pointer for the first string, right? Because we have to match it somehow, right? Yeah. And how to check if it's have a match or not? We check if the pointer of the I, which is the shorter one, moves to the other end. Yeah, either from the left to the right, move to the end, or from the right to the left, move to the beginning, right? The time complexity is OM, where M is the length of the longer string, right? Longer string. Okay, so any questions so far? Any idea? Any questions? Any questions?
No.
Where is this link? Okay.
Nothing.
Okay, let's it. Bye bye. Bye bye.
Bye.
Ryan, bye bye.
Bye.
Bye.